So we're going to look at briefly here about what it means when an object's kinetic energy changes. If you think about it, when you see kinetic energy changing, when you think about what kinetic energy changing is, what you're really looking at is velocity, speed, really. We can look at speed because direction doesn't matter for kinetic energy because it's a scalar. We're looking at speed changing. So you hear the phrase kinetic energy changes, or you want to think speed changes. Or, conversely, if you're looking at a problem and you see that the speed of an object changes, maybe it starts from rest and speeds up, or maybe it's already moving and slows down. Either way, the kinetic energy changed. It doesn't necessarily have to start from rest or come to rest. It could be in between. It could be moving and speed up a little bit and keep on moving. But if speed changes, kinetic energy changes. And if you know kinetic energy changes, you know the speed has to have changed. The only situation I can think of where kinetic energy would change and speed would not might be in the situation where you throw somebody out of your car. Your car would then, potentially, if it maintained the same speed, but even then, less force would be needed. So, you know what? We're not going to worry about that. If you see change in kinetic energy, you want to consider the fact that the speed is changing. Or if you know the speed's changing, in your head, alarms and bells should go off and say, wait a second, kinetic energy changing. I'll go through a couple of things. So obviously, the velocity changes. Big deal. Well, more than a whole video for that? Well, what you want to keep in mind here is, what does that mean with all the other physics that you've learned? Because if velocity changes, that change in velocity, the amount of that change, is called, it's called acceleration, right? So if there's a change in velocity, whether it comes to a stop or whether it speeds up, there's an acceleration present. But if there's an acceleration, there's only one thing in the universe that creates an acceleration. It's got to be a net force, right? Net force equals ma, Newton's second law. So, if you see an object, if you know an object's kinetic energy changes, you know it has an acceleration. And it must have a net force. And then you're going to pause and you're going to think back a couple videos. Go back, you think back a couple videos, you want to keep in mind, we talked about a net force a little bit ago. When we talked about the difference between work and net work. Remember, in order to have net work done, there needs to be a net force, and vice versa. If there is a net force on something, it will experience, there will be a net work done on it, provided the motion is in that direction or opposed to it, but suffice to say, it will likely be that way. So when an object's kinetic energy changes, I want you to really just simply think this. Changing kinetic energy, you want to automatically remember that means velocity changes, there must be an acceleration that isn't zero, and there is a net force that isn't zero. In other words, they exist. They're numbers other than, they might be negative, but they are not zero. So all of this is true, and if there's net force, what's to say, there's also got to be net work done on it. That is very important for the next video. Also, if you're looking at a problem and you see that somehow, some way, an object's velocity changes, it could be an object moving along that the driver hits the brakes and stops it. It had a velocity, and initially that might have been 20 meters per second, and it ends with a final velocity of 0. As soon as I see that, not only now that I'm becoming an experienced physics student, not only do I think in terms of kinematics, that's chump change at this point, I can also maybe consider that, maybe net force, right? But most importantly, I'm looking at this now saying, ooh, that object's kinetic energy changed. because that could open up a lot of possibilities. And by the way, would that change in kinetic energy for this situation, would you expect that to be positive or negative? I mean, I could help you. So we could go with 1,000 kilograms of mass. And I could point out to you that change in, if you recall from earlier this year, anytime you see that symbol change in, what you want to think of is it's always going to be the final value minus the initial. So in this case, change in kinetic energy, in all cases, change in kinetic energy is the final kinetic energy minus the initial kinetic energy. Well, wait a second. The initial was 1/2 1,000 times 20 squared. Certainly that is not a number that is 0, right? Now, I don't know what it is. You're going to have to 500 times 400. That's 20. 1, 2, 3, 4. It's 5 zeros after it. So, is that 2 million? 20 with 2. Let's see if I'm right. Now I got to know. But I'm not going to start hitting on the board because that thing led me wrong earlier. So we're going to go, let's see, 500, once we take half of the mass, times 20 squared. 200,000. Off by a factor of 10. You'll forgive me, right? It's late. All right? You'll forgive me. It's late. It's late. It's like 10:10. You're probably in bed by now. So, let me get rid of this erroneous 0. So 200,000 joules minus how much kinetic energy did? Oh, sorry. Whoops. Darn. See, I said it was 10:10, right? You guys see what I did? I just put the 200,000 where the final is, as opposed to be the initial. So I'm going to move that around. I'm going to take this, move it over here. There we go. Erase it. There we go. So going back, the final kinetic energy here is obviously 0 minus the original, which was 200,000. And making a short story very long is what I've done. Your change in kinetic energy here is negative. So if something slows down, its change in kinetic energy will be negative. It had less at the end than it had at the beginning. It lost kinetic energy. Cool? So while kinetic energy itself is not a vector and will never be negative, change in kinetic energy can be negative, because you can have a lot and lose some, or have a little bit. Either way, you lose velocity, you lose kinetic energy. That is a negative change. Now, another possibility for change in kinetic energy could be an object that is, actually, we could say an object that's falling, right? So you have an object that's falling. At 1 second, it might be going, 5 meters per second. And later on, it might be going 8 meters per second. If you knew the mass, you could find the kinetic energies, and that change, the object's moving down, so it should be a negative change, right? Please, right? No, it definitely sped up. It was right. This is where it was at the start, and then here it's going faster. That's a positive change in kinetic energy. See, kinetic energy is not a vector. I don't care that it's moving down. In fact, this thing's the force on it, right? Something's doing work on this thing. Gravity, right, is pulling down on this thing, and it's moving that way. So there's work being done on this thing, right? Not only that, there's net work being done. Why do I know there's net work being done? Well, because we talked about it a little bit ago. There's a connection here. If velocity changes, which it certainly did, that means there's got to be an acceleration. The acceleration can't be 0. It means there's a net force, so there must be net work being done on it. Let's talk about that in the next video.